All right, one more time. 12 grams of carbon. How many atoms is that? Do you know? That's all you know. 6.02 times 10 to the 23rd. Isn't that right? It's a mole, isn't it? And how many atoms would 12 grams of hydrogen be? Whoa, what do you think about that? It takes 1 gram of hydrogen to be a mole. I'm giving you what? I'm giving you 12 grams. What do you think about that? That's a lot, isn't it? So which one has more particles? 1 mole or 12 moles? 12 moles. And look at the next one. Which one contains a greater number of moles? See? 1 mole or 12 moles? Yes? Okay. Next one. The next most frequent question, miss, this one. Somebody got, you put B and B. It says, which one has the greater mass? Let's take a look. What is the mole of neon? And it's about 20.2 grams, somewhere around 20.2 grams. And what's a mole of uranium? Oh, that's 238 grams. So if it says which one has a greater mass, B. And almost everybody got that right. Got that? But why'd you miss this one? Look at the next one. Which one contains the greater number of atoms? Oh, how many atoms are in that guy? How many atoms, Kayla, you know, how many atoms are in 1 mole of neon? And how many atoms are in 1 mole of uranium? Is that right? Is that right? You got that? Aren't they the same number? Okay. Here, most of the time, almost all of you got this right. I have told you before, we use 3 sig figs. I do not use 35 for chlorine. I use 35.5. All right, 3 sig figs. So that was a minor thing for some of you. But if you put atoms here, molecules here, and formula units, see, ionic compound, covalent compound, whoops, off the screen. And this would be elements, right? 23, 18, 74.5. All right, you did very, very well. Let's go to the next part. I applaud you. I applaud those of you who did all 3 of these problems and got missed no points. That was great. That means you know how to do factor label. You know the 3 equivalents. You know how to put things in scientific notation. Okay, so anyway, here's what I was looking for here. And some of you didn't put in scientific notation. I didn't actually say to do that. I did say 3 sig figs. Okay. We're okay with that one. This one right here, almost all of you got that right. And the last one, you had to change kilograms into grams, and then you could do your 3 equivalents. You got that? And that's probably the only thing that some of you messed up a little bit on. Now, one thing, these are bonus questions, and I'm going to talk about this. This is a stretch. To me, I had not really taught this. I wanted to see, could anybody think their way through that one? This one, he actually did a problem like that right before the quiz started. Remember that? And so a lot of you did fairly well on that one. And, okay. Let's take a look down here. And a lot of you got this far. This many grams of aluminum oxide, and you want to change grams into moles, and you did that. You see that? But what is your label? What label would have been left? Some of you thought you were done, but your label says moles of aluminum oxide, but what do they ask for? What are they asking for? Aluminum ions. Okay, so here's a tough one, okay? And I haven't taught this. I wanted to see if anybody could do it. Some of you are very creative. I'll tell you another way that somebody did this problem and they got it right. It's a different way than I did it. I thought that was very creative. Raise your hand if you got 2 or 3 points on that. Okay, all right. Are you the one that used the percent composition? That's very creative, very resourceful. Okay. Here's the way you could do it, okay? And I'm going to teach this today. This is part of my lesson today. All right. Everybody see that? What is that made of? Starts with an I. Ions. Isn't that right? Isn't this made of what? For every one of these, how many aluminum ions do you get? 2. Really? So for every 1 mole of that, you get 2 moles of aluminum ions. So, and I understand I haven't taught that. It was a stretch. So here I have moles of aluminum oxide, but guess what? For every mole of aluminum oxide, how many moles of aluminum ions do you get? For every one of these, how many of these do you get? 2 moles. And so you put that in there, and that's how you got that answer there. I loved your creativity. What you did, you remembered the lesson on percent composition, didn't you? And so she went and found the percent. What was the percent composition? Was it 50?
52.9%.
53 point what?
52.9%.
I can't.
52.9.
No, 53? No.
52.
2. Okay, sorry. I hate math. So you found out that in the world of percent by mass, that 53.9% of the mass was aluminum. Is that right? Is that how you did it? And then also, then what you did was you figured out that, did you take 52.9% of what? Of the number of moles? Of this number here? Yeah.
No, I think
Didn't you take it?
percent first and then I multiplied.
Because if you had the number of moles here,
No, I found the percent first and then before I factor labeled.
oh, you did? Okay, but then, did you then take 53.9% of whatever you get here for the moles of aluminum? I think you did. Because the moles of aluminum oxide, you got some number here, didn't you? You said, well, 53.9% of those moles are aluminum. I think you did something like that. That was very creative. I never seen anybody do it like that. Okay, then the last one. Some of you were so close, and then just I don't know how you missed it, but we know that you change grams into moles, and we had this many moles. Now, you know what you could have done? What if you didn't want to change it to moles? What else could you change it to? And most of you changed it to something else. What did you do? Uh-oh, I lost you. Calculate the mass of carbon that have the same number of atoms. So what did you change it into? If I were you, what would I change it to? Atoms. Okay, fine. You'll still get it right. You can still get it right. So you found out how many atoms there were in neon. I found out how many moles, and guess what? It's still the world of number of particles. But you'll get the same answer. And so you had a number of atoms, is that right? Then you gave that same number of atoms to carbon, and then found out how many grams that would be, and it should come out to be very close to 3.3, 3.4, 3.37, something like that. Even if you did atoms, you should have gotten somewhere the same answer. I could do the same problem with atoms, you'll get the same answer. But if I do moles, I never have to worry about Avogadro's number either, do I? Okay. Well, anyway, these are bonus points. They're a little more subjective. I'm a little more harsh on the bonus points. But on the other hand, how many of you got at least one bonus point? Raise your hand if you got at least one. Okay, good. How about 2? How about 3? How about 4? How about 5? How about 6? Okay. All right. So I didn't expect anybody to get 6 bonus points, but all right, it happened. Questions on the quiz. What do you think? I think some of you were real nervous when you heard it had a quiz yesterday, and I didn't give it till the second half of the period. Were you okay with that? Were you okay? You felt better? How about now? Do you think it was fair? Is it fair? Okay. All right. So what I'd like to do now is the homework that was going to be due yesterday, but yeah, I think you were a little just too nervous about. I just thought let's go ahead and move the homework to Monday, so then you don't have to worry about being overloaded. All right, so what I'm going to do is I'd be willing to, I'll show you a problem I definitely want you to do, and this is kind of part of my lesson today. I think one of the hardest ones here I think one of the hardest ones is 16B. Okay, and I'll do one more too. So, okay, and if you want to do 23, I can do that too. Yes. So I know I'm going to do 16B, and I know I'm going to do 23. Those are I love those. But is there another one? 18? Okay. 18 is going to be like this one. It's going to be like it. So I'm going to do this one, and then maybe see if you tell me that answers this, how to do that one, then you'll be able to do that, okay? All right, let's take a look at 16b. Okay, 16b. Now, the problem says 8 grams of calcium chloride, 8 grams of calcium chloride is dissolved in 1 kilogram of water. How many moles of calcium chloride are in solution? And how many moles of water? Okay, so we'll do that anyway. We'll go ahead and do that. We know that almost always in chemistry, if you can get in the mole world, you can answer a lot of chemistry questions. So who knows how to do that? Who wants to volunteer and say, I'll walk you through this. How do I change this into moles? Who wants to try that? All right, Caroline? What you got?
Try to get rid of grams of calcium chloride.
Yes.
So, calcium is 4
Okay, and then we're going to change it into.
moles. So 1 mole of calcium chloride.
Calcium chloride. And so let's find the molar mass. How about that? I will tell you that 35.5 and 35.5 is 71. Okay, and what's calcium? About 40.1. Okay, so we got 71 plus 40.1 is 111.1. Is that right? Is that right? Okay. All right. So now, what I'm going to do is let's go ahead and get this number, because I know if we get the moles of calcium chloride, we can actually do the whole problem. They have a calculator they can hit this on, and we're going to use 3 sig figs, and if we can use scientific notation, I'd like to do that also. So 8 divided by 111.1. Who's got it? You have it already? Okay, what is it?
7.20 times 10 to the negative 2.
10 negative 3?
2.
Sorry. And that's moles? Okay. Did everybody get this? If you put this in a calc, is that what you got or not? Okay. And by the way, they ask you to do water, but I think if you can do calcium chloride, I'll bet you can do water, can't you? I bet you can do the water part, can't you? Now, what I want to do is go to 16b. And it says, assume that the ionic compound separates completely into those ions when dissolved. How many moles of each ion are present in the solution? And this is where the beauty comes in, okay? Here we go. We have 7.2 times 10 to the minus 2 what? This is where labels come in handy. Moles of what? Calcium chloride. Did everybody get that? I'm looking at your faces. Yes? What are they asking me for? How many moles of each ion? What? How am I supposed to know that? How am I supposed to know that? All right, ready? For every one of these, and by the way, this stands for 2 things. In the little world, it says one of these ions is combined with what? One of these calcium ions is combined with what? 2 chloride ions. Is that right? What else can CaCl mean in the big world? In the big world, mole. This is 1 mole of calcium chloride. It says what? 1. If I give you a mole here, okay, I lost you. If I give you 1 mole of that, how many moles of calcium ions are in there? A mole. And how many moles of chloride ions there? 2 moles. What? You can do that? Now, if you want to use factor label, I can do it, or I can just use my head and say, for every one of those, you get 1 of those, don't you? So what if I don't give you 1 mole of that? What if I give you this many moles? If I give you this many moles of that, then how many moles of that did I give you? Does that make sense to you? One more time. If I give you 1 mole of that, I give you 1 mole of that and 2 moles of that, didn't I? What if I give you 2 moles of that? What if I give you 2 moles of that? What's that mean? Look at him, look at him. If I give you 2 moles of that, what's that mean? I would have given you, here, let's try it again. What if I give you 2 moles of that? Then how many moles of calcium do you have? 2. And how many moles of chloride do you have? 4. What if I don't put a 2 there? I put this funny weird number, okay? What if I give you this many moles of that? How many moles of calcium does that give you? This number. And what about moles of the other ion, the chloride ion? For every one of these, you get what? Twice as many moles. So if you put that in a calculator for me, I think you're going to get 144. Is it 1.44 times 10 to the, oh, dang it. Let's see. What is it? -1? Yeah. Okay, now, so that's where part of this chapter is conceptual. Part of it is, what's the concept of the mole? And the other part is, can you just do the math? Can you just do the math? You get it? But without the conceptual part, you're going to miss a lot of questions because you just, I don't understand what you're talking about. You had asked, all right, Noah, you had asked about number 18. Take a quick look at 18. Do you see where it tells you how many grams of ammonium chloride they give you? See that? What if you were to change that to moles? Can you, would you be able to do that real fast or not? Take 10.7 and divide it by, let's see, 35.5 plus 4, that's 39.5, plus 14, 53.5, is that right? Is that right? Is it 53.5? 40, 50, yeah. Yeah, is that right? Did you get a molar mass of 53.5? Okay, so even though I'm not supposed to show you the shortcut right now, I'm going to do a shortcut. I will eventually show you some shortcuts. You get that? Hey, I will show you the shortcut later, but let me show you real quickly. Do you know every time you change grams into moles, you know what you always end up doing? Now, by the way, on the test, I'll make you show your work, but what do you do when you change grams to moles every time? Don't you always divide by the molar mass? So what I'm going to do here is, I've got 10.7 grams. I'm going to do a quickie. This is a shortcut. I'm going to divide by the molar mass. All right, can you give me a hit on that? What's 10.7 divided by 53.3? 5. 53.5. How much? 0.3 even? 0.2 even? Oh, all right, that's neat. All right, here we go. Now, watch. 0.2 moles of ammonium chloride. All right. Now, go ahead. Ask away. If you dissolve that many grams, that's this many moles, how many moles of ions would be in solution? I love this question. This is great. Ready? One more time. For every 1 mole of that, how many moles of ammonium do you have? 1. And how many moles of chloride do you have? 1. What if I give you 2 moles of that? What if I give you 2 moles of this? How many moles of ammonium did I give you? 2. And how many moles of chloride ions? 2. What if I give you 0.2 moles of this? Then I give you what? 22 moles of ammonium ions. And what else did I give you? 0.2 moles of, does that make sense? Yes, no? So it says here, how many moles of ions of any kind? How many moles of any kind of ions? Well, I have 0.2 moles of those ions. I have 0.2 moles of that. I'll bet the answer is what? 0.4 moles of any kind of ions. Isn't that right? Okay, so there's at least 2 of the harder questions on there, okay? How about, you want to do 23 real quickly or not? Would you like to do one more? It's just one less you have to do for homework, isn't it? All right, let's take a look at 23. And there we go. All right, ready to go. 23. A chemist weighs a steel cylinder of compressed oxygen and finds it has a mass of 1,027 grams. You know what I like to do? I like to make little pictures. Let's make some pictures. What's this? There's some cylinder valve here. Okay, so how much does this thing weigh? Okay, and then he used some of the oxygen in an experiment and found out that weighed, how much did it weigh later? 1,020, whoops. 100, I forgot that's off my 8, didn't I? Okay, so 1,027.8 grams, and then 1,023.2 grams. Well, what am I going to do with those 2 numbers? You weigh this, I use some of the oxygen, now you weigh less. What does that tell me? Let's see, oxygen plus cylinder weighs this much. Oxygen plus cylinder later weighs this much. I don't think I lost any cylinder. I lost oxygen, didn't I? So subtract that, what do you get? Everybody. 4 point what? Isn't it 4.6? 4.6 what? Grams of what? Oxygen? O or O2? All right, well, I'm ready to go now. There you go. That's all I really needed is I have this many grams of oxygen. And what's the question say? How many what? Moles? I can do that. All right, what are you going to do here? Did everybody get this? I hate it. I hate if you're just sitting there copying me. I want you to think about it. If you're ahead of me right now, that's great. And if you make mistakes, I can fix it. But Elizabeth, tell me what I'm going to write here, okay? I bet you know. Watch. You got an A on this quiz, didn't you? All right, so you should know. Tell me what to do.
You'll put 32 grams of
32? Why 32?
because you have 2 moles of oxygen,
That's right.
and then on the top you put 1 mole.
Yes. Not. See, you probably never thought you could be good at this. You're good at this. You're good at this. What do you think? Now you put that in a calculator, and I think that should be the answer, shouldn't it? But when you first read that problem, were you going like, what the heck kind of homework is this? This is difficult. What do you think? Do you trust me in saying that labels are important? Do you understand that? Labels are important. Okay, I think I'm about done with that. I need to move on a little bit. So that helped you with homework, right? We went over the quiz, and now what I'm going to do is I would like to get to the last part of the chapter. Believe it or not, I'll be done teaching on Monday. Right now, the test is either Thursday or Friday next week. I might push it to Friday to give you that one extra day. I might even have like a day where I give you a practice test or something like that. I might do that. So the earliest it could be is Thursday, and the latest it would be is next Friday. Got that? So I'm going to be done teaching on Monday. Okay. All right. So what I'm going to do, I lost my paper. Here it is. There's one more section in the book. And if you, let's say, I'm going to agree with you. If you look at this chapter, he has like 8 or 9 pages where he changes moles into grams or grams into moles, and we know how to do that, don't we? I could see you not really looking at that section because we know how to do it, don't we? Matter of fact, maybe he does it a little differently, and I might mess you up. But I would like to encourage you. I would like to encourage you to go and make sure you read by next week, starting where it's right there on 8.6. It's called section 8.6. So I highly encourage you to read this after the lesson, okay? And I'll do this lesson again on Monday. You get it? I'll do this lesson again on Monday. But you say, well, okay, I got the lesson down and read it and said, oh, that's not as hard as I thought. So here, when chemists were trying to figure out things long ago, they said they had something in their hand. They said, what is this? I don't know. How can you find out? I don't know. I read about somebody who did this, and they were able to weigh something, and they were able to do this, and it took a while. It took a long time before chemists figured out, how do we find out what something is? Now today, we are pretty good at it. Can I tell you? We have machines. We have a mass spectrometer, for example. And you can put a sample in there, and it'll pretty much identify, of course, it's connected to a computer library, and it can identify something pretty quickly. You know, you ever watch some of these shows like NCIS, or you ever watch some of these? You guys watch TV at all? That's right. But even if you don't, the police departments at all the major cities, for sure, they have some of these machines. They have chemists they work for the police department, and they do lab stuff. Like you get evidence. Quick, I need to know what's this substance on this bullet. I gotta know what it is, you know, and they might need to know within 24 hours. Now they have machines that can do that, and the machines are like, you know, maybe $250,000, but they're really good. They're really good at what they do. So, but before the mass spectrometer, we had to do the painstaking way of, you know, probably react it with oxygen, find out how much mass it gained, how much mass it lost. It was not easy. But the mole concept was everything. When the mole concept came around, it broke open chemistry quite a bit. So what I'm going to tell you here is, you might ask, why do I need to know about an empirical formula versus the regular chemical formula? It's because almost every time you analyze something, it gives you the lowest whole number ratio of the elements. Now, I remember the first time I heard this, I don't think it explained well for me because I didn't understand it, but I'll make it easier for you. Let's take a chemical like this, C6H12. Everybody remember this from biology class, glucose? You remember that? That is the chemical formula. It is, okay? I'll draw another one. How about this? Oh, that is the chemical formula for water. Let's do another one. How about, here's one, you don't know this chemical. It's called acetylene. Acetylene torches. Have you heard of acetylene torches? They're real hot. They can burn right through steel. Okay. Anyway, acetylene is that guy right there. I'll do one more. Let's see. There you go. I'll do that one. How about that? Let's do another one more. Yeah, let's do that one. How about that? All right, ready? Now, we know that these are real chemicals, and they are those are the formulas for that chemical. Now, what is the empirical formula? The empirical formula is the lowest whole number ratio of those atoms. So what do you think the empirical formula for glucose is? What's the empirical formula for glucose? Say it again. It is. Remember, the only subscript never written in chemistry is 1, right? So if you were to, quote, reduce it, oh, that's what you mean by empirical formula. Yeah, reduce it to the lowest whole number ratio. If you divide all these by 6, don't you get that? Now, it just so happens that there's no such thing as that chemical. But if you were doing an analysis of that, your analysis would show for every one part of that, you would get 2 parts of that and 1 part of that. That's what it would show. Another analysis would tell you to multiply all these by 6. Let me show you another chemical. What about this guy? C12H12. H24O12. What would the empirical formula be for C12H24O12? Okay, now I think I got you here. So therefore, could two different chemicals have the same empirical formula? And so we'd have to have another test. The analysis of the lab says it's this. And then they had to do another test to tell me, hey, the real chemical, is it this one or this one? Or is it this one? You see that? All of these would have the same empirical formula, wouldn't it? Yes? Okay, now watch this now. What's the empirical formula for water? Okay, can a compound have the same chemical formula as its molecular formula? Can it or not? It can it? What is the empirical formula for acetylene? Okay, now there's no such thing as this chemical. That's called the empirical formula. If somebody did an analysis, they'd say, for every 1 mole of that, you're going to get 1 mole of that. It's a 1-to-1 ratio. And what about carbon dioxide's empirical formula? Okay. And, that's interesting. I never know exactly how much money I have. I don't use money a lot. I'm going to see something. Oh, I have $1. Oh, yeah. I'm going to give $1 to somebody. Now, I want to mention that many molecular compounds or covalent compounds, many of them do have a different empirical formula as their regular chemical. And even this one, this is a molecular compound, but some molecular compounds, some covalent compounds, do have the same empirical as they do that. But when you get down to here, there's something different about that chemical than all the rest of those, and it's ionic, isn't it? Isn't it a metal and a non-metal? So this is ionic, isn't it? Now, here's my question to you. Did you know that 99.999% of all the ionic compounds, they are already the lowest whole number ratio? They'll always be the same as their empirical formula, except for which ones? Raise your hand and then say the answer, and I'll say yes or no. All ionic compounds are always, they're also the empirical formula, except for which ones? I'll keep that right there. And if you think you come up with the answer, you just raise your hand and say, I think I got it. For example, what is we know there's a chemical called NaCl, and what is the empirical formula? It is that chemical, isn't it? Let's do another one. How about barium chloride? What is this empirical formula? See? For ionic compounds, they are the lowest, they are already in the lowest whole number ratio, except for which ionic compound? Okay, I'll leave that open, and there's just an exception to that rule. All right, so anyway, if you want to come up with that, let me know, and I'll get you $1. You can buy something with it. Okay, I'll leave it right there. I'll leave it right there for the rest of the period, okay? But as soon as you get it, you raise your hand, and I'll let you answer it, okay? All right, so now what I'm going to do is I want to show you how this works. How do we do this? How do we find out the empirical formula for something like this? All right, and what I'm going to do is I'm going to go to the book, and they have a problem to do. And here we go. If you have your book with you, go to page 223. If not, I'm going to be using my book right there. Let me get a piece of paper here. This is what I do like about the book. If you want some sample problems, they not only do them for you, they actually show you how to do them. So look at the original question. I'm going to magnify that because I don't think you can see that very well. And don't forget about that $1. Okay. all ionic compounds are empirical except for which one? All ionic compounds are already reduced to the lowest whole number ratio except for which ones? Yes. Oh man, what? Yes. Now, even though hydrogen peroxide is not ionic, but other peroxides would be, like sodium peroxide. And so, for example, what is the what's the compound? Let's do this. Ready? Here's sodium oxide. What's sodium peroxide? See that? And guess what? That's here, I'll give it to you. The peroxides are the only time you'll see where an ionic compound is actually, thank you, is not also the empirical formula. So, all right, here we go. So let's take a look at the problem, and it says here, an oxide of aluminum is formed by the reaction of 4.151 grams of aluminum and 90 grams of oxygen. Calculate the empirical formula. I'll tell you what, when I was your age, there's no way. Does anybody have any idea how to even start this problem? Okay, that's good. That's good. Now you're ready to learn. Now, I want to show you something. If I want to find any formula of any chemical, what world do I have to be in? And I know you don't like me saying this, but what world do I have to be in when I look at a formula? Am I in the world of mass? Does this say 2 grams of hydrogen is found with 1 gram of oxygen? Is that what that is? What world are you in if you want to be in the formula world? And I'll give you a clue. It's the world of number of particles. I need 2 of those particles combined with 1 of those. Now, what word means you're in the world of number of particles? What is it? Mole. If you're going to do any kind of formula, you have to get into the mole world. You have to. You get it? So let's try the problem again. What are they going to give me again? It says I have 1.51, whoa, that's not true, 4.151 grams of what? Aluminum. And then I have, let's see, what's the next one? 3.8. Oh, I can't see now. Whoa, what happened? 692. 3.692. I couldn't see that. Grams of oxygen. Now, in this case, because they separated this compound, it's not diatomic oxygen. They had grams of oxygen atoms. You get that? Because they all right. So that's what we're doing. So guess what? The first thing I have to do. What do you have to do? What world do I have to get into? I'm in the mass world. I cannot find a formula in the mass world. All right, go ahead and do it. Go in, get into the mole world right now. Everybody in here should be able to do this. I'm just waiting. You just go ahead. You beat me, all right? I'll put a pause on here. Let's get into the world of moles. Calculator. Oh, calculator. Oh. Oh, it's over there. Okay. Here's my phone. Okay, did everybody get something like this? All right. Now, this is something that is kind of interesting. I don't know how much math you like, whether you like math at all, but here's the answer. It looks like your chemical is going to be Al 0.1540.231. Yeah, I've seen that in many chemistry books, haven't you? None. I've never seen that in a chemistry book. So I'm going to show you a trick. This is a math trick, okay? If you have some, I call these ugly looking numbers. If you have some ugly looking numbers and you're trying to find the lowest whole number ratio to make them not look so ugly, there's a little trick. And what you do is you divide by the smallest. In this case, the smaller one. Divide both of them by the smaller. All right, watch now. Which one's smaller? Which one of these is smaller? You have to know that. All right, now divide both of them by the smaller. I'll bet you get one up here, don't you? Do you get one here? Yes? All right, do the other one. Remember, don't ever go below 3 sig figs, okay? Don't go below 3 sig figs. What do you have on the second one? I'm hoping. What do you have, Kayla? What's? What? Yes. Yes. Now, are you with me? We are very, very close. 1.5. I need the lowest whole number ratio. Now, does anybody know what you had to do to this number to make it a whole number? Does everybody know? What? Do you know that's 3 halves, right? What do you have to do to 1.5 to make it a whole number? Multiply by what? 2. All right, multiply this times 2, and what do you get? But wait, you had to maintain this ratio. If you multiply me times 2, you got to multiply the other one times 2. Okay, I will. Now, what's my final answer? When analyzing this compound, we know that in the mole world, darn. Okay, this is the crucial sentence today. In the mole world, my analysis shows for every what? For every 2 moles of aluminum, you will have what? Ding, 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 ding. And guess what? That is how you write aluminum oxide, isn't it? Yes. I'm sorry. Okay, because the chemical itself was made of aluminum and oxygen, and the oxygen in a compound is just oxygen atoms, because it's in a compound somewhere. But like if I looked at C6H12, that's not O2. Oh, the numbers?
Yeah, like when I got the answer, I rounded it to 1.47 and 1.5.
Okay, now, you could leave it as, you had 1.47 here? When you did this, did you get 1.47? Okay, did you have something like this? Now, I would tell you that if you get something like, 1.01, that's 1. If you get like 1.49, that's 1.5. I will tell you, 1.2, though, is not 1. You shouldn't get 1.2. But anyway, I think it's kind of neat how they did this without having a mass spectrometer. They just did it this the old-fashioned way by weighing it and the mole concept. Okay. Hello. Okay. Oh, no, Ramos. During the break, they need they got something dropped off. Somebody dropped something off or something in the office. All right. What do you think so far? Huh? Okay, we're gonna do another on Monday. We'll do this again. You get that? On Monday, we'll do this again. I'm gonna show you just real quickly. Won't take very long. What time we get here? 10 after? 5 after?
It's the 10th.
Oh, I get confused with Oh.
No, yeah. We get out here at 10 after. Okay.
Oh, I'm sorry.
So that's right. Well, anyway, so just give me about 2 more minutes, and I do want you to have a nice weekend. It's going to be sunny, a little bit cool. Like that. So I only did one of these problems, just one. And we'll do a couple more, maybe 3 more on Monday, and just said, you know what? I think I got this thing down, and that'll be the end of the chapter. The end of the chapter will be on Monday. Then my plan is to maybe part of Monday, have you start this thing called certification. Now, certification is where I made up a little booklet, and I walk around the room. You can't ask anybody else for help. If you need help from me, I'll help you. And what you do is you do these problems. And as soon as you get the problem done, I check it and said, I put my initials on it and said, well, you know what? You're certified. You know how to do that kind of problem. And then you'll get points for being certified. That's good. And then also it's good practice to get ready for the test. So I haven't decided whether I'm going to give you the practice test first and then certification, or certification, which one of those two. So it'll be one of those two. All right, but the last thing I want to do is I want to show you something that's kind of neat. The last 2 pages of the chapter. The last 2 pages of the chapter are the easy. Okay? So let me show you how it is. Ready? I want you to pretend that someone has analyzed your chemical and they found the empirical formula was that right there. Okay, let's pretend. And then someone else in another department of the chemistry lab said, I also found something else out. I found out that your molar mass, I had a way of figuring out molar mass. Your molar mass was 180 grams per mole. So which one of these chemicals is it? And I'll show you, this is the neat part about chemistry. Ready? What you do is take the empirical formula and tell me how much it weighs. What is the empirical mass? All right, what's the mass of CH2O? Let's see, it's 12 plus 2 plus 16. What is that? Is that 30? Okay, so your empirical formula has a mass of 30. Now, it has to have this ratio, doesn't it? It has to. But your real one weighs how much? So how many times would I have to multiply the empirical mass to get to 180? Or another way of doing it is divide, right? How many times do I have to multiply 30 to get there? 6. So take the empirical formula and multiply it by 6. 6, 12, 6. Oh, that's neat. And by the way, if you were to add all those masses up, guess what you would get? Now let's pretend again. I have another chemical, same chemical, or not same, different chemical, and somebody says the molar mass was 90. What if the molar mass was 90? Okay, well my empirical formula has a mass of how much? 30, but the real chemical has a mass of 90. I wonder what that could be. How many times would I need to multiply this to get there? 3, so take your empirical times 3, and what's this chemical? Oh man, and that's what the last 2 pages of the chapter are, okay? All right, well thank you, you did a great job, great job. Congratulations on the quiz. Almost every one of you did very, very well. If you got an A or B, if you got an A or B in that quiz, you pretty much know what you're doing. Even if you got a C, you probably figured out what your mistakes were. Hey, have a nice weekend.
Oh, speaking, I have a question about my quiz.
Okay.
So,
You can look at it?
yeah.
Yeah.
I just want to, how much were these, like, 2 worth?
Oh, okay.
Were they each
So-
worth 1, or?
So what I did was 3 points apiece, but I'll tell you how nice I am.
Okay.
If you only missed 1, I didn't take off 1.5, I only took off 1. So if there were 2 parts and you missed half, I didn't take off 1.5 out of 3.
Okay, so that's where you got the 4.
So that's where I got that. But if you missed a whole question, the whole questions are worth 3.
Okay.
So anyway, if you miss both parts, you don't get any credit. So
Okay, yeah.
you
I understand that
And you
stuff
did the
now.
right thing. Oh man.
Yeah.
Woo. You're good.
Yeah, I understand that now.
How about
you explained in class, I understand.
And you did a good job.
Yeah, thank you.